Is a message queue in an a9s messaging cluster really high available? My name is Patrick Hartz, and today we will give you important information on how message queues behaves on an a9s messaging cluster. Last time I showed an easy way how to push two applications to Cloud Foundry and bind them to a formally deployed a9s messaging service instance. We also talked about what a9s messaging is and what's going on behind the scene. In the video series about the a9s PostgreSQL data service, we already discussed the horizontal and vertical scaling. Scaling is supported in all a9s data services, which are present in the a9s data service framework. We can either scale an instance horizontally, which means we add more nodes and form a cluster, or we can scale the instance vertically by increasing the memory, the disk space, or the number of CPUs. To update the instance horizontally, we will use the cf_update command. But before we do this, we will check which service plan is assigned to the service instance. This command will help us. As you can see, the service instance is created with the messaging single small plan. For an update to a clustered instance, we will assign the messaging cluster small plan to the service instance. This is the command we are using for the instance update. We already know that Bosch is taking the virtual machine down, is creating a new one, and attaches the persistent disk again to the new instance. As we are updating it to a clustered plan, Bosch is creating two additional virtual machines, and then the data service framework automation combines all the nodes to a clustered instance. Keep in mind that this update causes a downtime of your service instance. So let's see if the update is succeeded. Perfect. Now we can scale the instance vertically. To do that, we use the same command. But in this case, we apply another service plan to the instance. We will choose the messaging cluster medium plan. In the videos about the a9s PostgreSQL service, I told you that this update causes no downtime. This is not entirely true in the case of the a9s messaging service. Yes, okay, Bosch is updating each node one by one, and the cluster is somehow reachable during this time. But RabbitMQ is a multi-master system, and queues are not present on each node by default. So if the node is getting updated where a queue is located, the queue is not reachable in this time. You can avoid this by marking the queue as high available. Also in this case, the queue is just on 2 of 3 nodes of the cluster. It's always n-1. In the next part of this video series, I will show you how you can mark your queue as high available. To enable this protocol, you can use the plugin mechanism which comes with the a9s data service framework. You can check the online documentation to see which other plugins are available. The command we use enabling the plugins is also the cf_update command. The -c parameter tells the automation which plugins to enable. To enable more plugins at the same time, you can combine them, as the plugins parameter expects an array. But keep in mind, if you add a new parameter, you have to add it to the list of all parameters. Parameters which are not in the list will be disabled then. RabbitMQ is based for a9s messaging, and it supports different user roles. This is important in the case you want to access the dashboard which comes with the a9s RabbitMQ. You can read more about the different user roles in its documentation. Let's create a service key. When the service key is created, you can retrieve the needed information with this command. This is a lot of information. We will need this information in the next video. What are the learnings for this video? We know how easy it is to scale an instance horizontally and vertically. We enabled a plugin and we also created users. But the most important thing is that we now know that queues are not by default high available in a9s messaging cluster. Marking the queues as high available and opening the RabbitMQ dashboard is the topic for part 3 of the video series.